So, with r and theta, real quick. So let me do this. I think I'll do this. I'll kind of do a little bit from 10-4. Again, 10-4 is extra credit all the way around. But I do want to kind of talk a little bit about 10-4. And then we'll open it up to full review about Chapter 10. You can ask anything you want to. So the test is officially 10-1 through 10-3 with some bonus from 10-4. I'm going to leave that up there. Somebody, it's kind of like calculus can use a little sprucing up. So, polar coordinate calculus. Holy crap. You're dying, poor little dude. How are you doing? You're a little better? So, recall, if I had a parametrically defined set of equations, how did I figure out dy dx?
You have to find dt dy and dt dx, right? Oh, yeah.
So I do dy dt, because I can, over dx dt. So philosophically, there's a disagreement between Newton, Leibniz, and Lagrange. They were kind of like the three big ones in terms of notation. Newton liked the idea of infinitesimals. The other two guys didn't really. I'm a Newtonian person myself. I'm completely fine with infinitesimals. So, of course, these algebraically are the same, yes? But what's interesting is I'm manipulating symbols that leads me to do a process that this doesn't even ask for. What process is that? I would take the derivative of the y over the derivative of the x. And that is mine. And then if I plug a value in, I get m. And then I can figure out equations of tangent lines and shit, just like in calculus. You with me? A little bit? A little bit? Okay, so that's the recall piece. So here comes the new stuff. See if you're working. Ooh, okay. So now if I have polar, given polar coordinates and coordinate system and equations. So that means, so if I'm given some r as a function of theta, right? So r could be sine theta, it could be 2 sine 2 theta. I think last time we did 4 sine 2 theta, and we did all the 4 leaves. Do you remember doing that? It went wee, wee, holy shit. Okay. So r is some function of theta. Okay. In polar, how do I express x and y? What is it just in general? What are they?
X is r cosine.
R cosine theta, kick ass.
R sine theta.
R sine theta, kick ass. And now, does anyone really still disagree with me about, I hate SOHCAHTOA. They should, from the beginning, teach cosine likes x, sine likes y. Everything's so much easier, and then that makes stupid sense. Cosine goes to x, sine goes to y. Okay. So, I am going to get rid of this art somebody put up here. So let's do something exactly the same way we did for parametric. If I want to know dy dx, wasn't y a function of theta? In fact, y, let's see if you guys are with me. What is r in this situation? What's true, but more specifically?
X over.
No, don't look at that. What is r? It's a function of theta, yes?
Yeah.
Okay. So don't I just want to do this? dy d theta. Right? Exactly like we did with t. Isn't theta sort of acting like t? Not perfectly, but you can see how that's sort of another kind of way to think of it as a parameter, right? Okay, I like it. And so to do this, I've got to realize, isn't r a function of theta? Yes. Isn't cosine theta a function of theta? Well, yeah. Okay. So when I do the derivative of y, for example, is gonna be dr d theta sine theta plus r cosine theta. Good old product rule, right? Take the derivative of r sine theta, it's gonna be derivative of r times sine plus r times the derivative of sine. Over, same thing for dx d theta, so now it's gonna be dr d theta times cosine. And of course, it's going to become a minus when I do the derivative of cosine. So this is how you would figure out the slope of a polar defined function. Okay, maybe. So I mean, for example, if I had that graph we had last time that looked like this. Holy shit, Jeff, not there. There we go, buddy. Right? Pretend like that's what it looked like. And I wanted the slope, I want to know the equation of the tangent line right there. I want to know that tangent line. I would much rather have it defined in rectangular coordinates. So this is how I can actually figure out what dy dx is. And right there, it looks like it should be positive. Yeah, looks like maybe it's a little more than 1 and so forth from my horrible picture, but still. You guys follow a little bit? I mean, I really want you to see it's the same motivation as this was. I have x and y as functions of t's. Here I have x and y as functions of theta. I can do the exact same thing we did to create this. I can do the exact same thing. It's beautiful. Just to remind you guys, this is all extra credit. I just can't let you out of here without at least showing it to you a little bit, right? Now, does that look as nice as that? No. So parametric is not as big a step away from xy as polar is. Do you guys agree with that statement? Do you understand what I mean? I mean, parametric is basically still xy, isn't it? It's still xy. So the derivative shouldn't be that horrible. R theta is a completely different way to find points. You would expect the derivative to look kind of gross because it's a completely different freaking thing. It's sort of like going from gallons to cups versus going from gallons to milliliters, right? The second one is kind of, the first one's stupid, by the way. I don't know how many cups are in a gallon, but I don't know. You guys semi with me? Definitely going from our crazy ass units that are based on how big the king of England's foot was to the rest of the known world. It would be weird, and it is. So that's why this is gross. I expect it to be gross. It's a completely foreign, different way to identify points. Okay, enough, Jeff. I think you get the idea. Now, real quick. I'm doing this a little bit quick because it's not a full thing. It's a bonus section, so you guys can try it if you want to. If you're going into Calc 3, I highly recommend you do at least look through 10.4, maybe try a couple out, okay? Because Calc 3 is going to be about taking parametric and polar and taking them into the third dimension and then, beyond. Oh yeah. So maybe take a look. Okay. So, can you guys, what if I have a polar function? Yeah, let's say one thing of this. And I want to know the area of that leaf. What does it sound like I want to do? Area. I want to integrate. Yes? Okay. So I'm given an r as a function of theta. And I want to know what that area is. By the way, I really want this to make sense. If r is pi over 4, that's r there, right? You with me? Yeah. If r is pi over 6, maybe it's there. If r is smaller, it's there, so forth, right? This is kind of cool. So if I think about, remember when we had XY stuff, and we had this infamous picture that your teacher in Calc 1 drew a lot, right? Here's your f of x, how do you find the area? Well, you break it up into little rectangles and you go into 6. Yeah. And you up the resolution to infinity by using infinite rectangles and so forth, okay, right? So watch this. As I move around, I could basically break this up into little, it's horrible, Jeff, hold on, into little slivers, little triangles. Now, not rectangles, but triangles, right? Let me kind of make one big so you guys can really maybe see what I'm talking about there. So I can break it up into triangles. Now, of course, it's going to be infinitesimally small. Now, help me out. As I swing through this, what's changing, of course, as I swing through it? The angle. So this side here is d theta. Is that cool? That's the sweep. It's like a radar sweep, right? Okay, I like it. This, of course, is r. Now, d theta is stupid tiny. And if I have something curved, but I zoom in a ton, doesn't it look flat? Right? And again, flat earthers, blah, 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 blah. Okay. So isn't this really a triangle? What is the area of that triangle? Because if I can figure out the area of that one triangle, I just have to integrate all of them, just like we did with rectangles back in the day. What is the area of that triangle?
1/2 r times 2 theta.
Almost. So let me see, how do I say this? Yeah, one thing I'm kind of not showing you here that I need to show you. Let me show you. Okay, let me really make this quick. So this is basically r here, right? That's the height. What is this arc length? Let me be a little more helpful. What's arc length? Does anyone remember the formula for arc length? R theta? You guys remember that? No? No? Does it look familiar? Oh, well, that's what it is. So this is actually r d theta. That's the length of this, right? So what's the area of this triangle? It'll be 1/2 r squared d theta. And that's going to be the little element of area. So then how do I figure out if I'm given, again, this specific one was, I think, 4 sine 2 theta, the one we did the other day. It's actually the one that's on the practice test, so. 4 sine 2 theta, I think we did that one the other day. If I want to figure this out, I would just do the integral of 1/2 r squared d theta, where r is equal to 4 sine 2 theta. Just throw that in there. Now, what would I integrate from to? Where does this, what angle does this start at? 0. And then what angle does it, here it's pi over 4, right? So what angle does it go to? Pi over 2. So I go from 0 to pi over 2. You do it, Jeff. So just throw r equal 4 sine 2 theta in there. Check, maybe. All right. Okay. Believe it or not, that's it. So you can imagine, just like when you first learned integration, they started to throw things at you like find the area between these two functions, find the area, and the functions would crisscross, right? Remember that stuff? You have to figure out where do they meet and which one is on top now and blah, blah, blah. Remember those things? So in this section, if you choose to do the homework and get some extra credit possibly, you're going to see problems like find the area that is outside the circle, find area outside r equal to cosine theta, but inside r equal to whatever, cosine 2 theta or something. So what do you think, even if you don't really understand what that looks like and what that means, what do you think the first step needs to be? The same way as it was back in the day here. What's the very first step I need to do? Find where those two intersect. That's going to determine what the bounds are. Maybe? Okay. Again, you don't have to do 10-4. But again, if you're going to Calc 3, you still don't have to do it. But I would highly recommend you try a few out at the very least. Right? It's not crazy difficult. But that does get it can get a little bit weird, especially because we don't know exactly. If I said what's y equals x squared look like, you all know what the hell that is. If I said what does r equal to cosine of 3 theta look like, you go, shit, I don't know. Because again, it's just like not knowing how long a freaking decimeter is. Can you show me how long a decimeter is? No, I don't. Okay, maybe. Because we just don't use them. Okay. So that's all I wanted to say about 10.4, unless somebody has a question specifically about it. But let me ask this now that more people are here. Anybody still need the practice test? I'm sorry, I tried to be nice on the back and give you guys a graph, but of course my printer had different ideas. So now it's wide open. We can talk about anything from chapter 10 that you want to. So just to kind of remind you guys, this Wednesday is the test. I'll have it graded by next Tuesday. Next week we have 2 days of nothing but review for the final. I do have a practice final I will give you this Wednesday. I will have an answer key for it next Tuesday, next Monday. Cool. I'll try not to bring that to my other class. That would probably freak them out a little bit. So it's wide open to whatever you want to look at. Do you have issues from homework? Have you tried the practice test out? If not, go ahead and try it now. You can ask questions as you hit them. Yes? Yeah. So one thing I want to remind you about, if you don't have this now, you need it immediately soon, is you need to memorize the conversions for polar. So who can tell me anything about converting between x, y, and r theta? Give me anything you know.
Y equals r cosine theta. R sine theta, sorry. And then x equals r cosine theta.
All right. Somebody else give me something else.
Theta equals inverse tangent of whatever x.
All right. Somebody else give me the last piece.
R squared equals x squared plus y squared.
You can ask. All right. So if you're given 2 points, it's pretty straightforward. If I give you r and theta, you just plug them in here and you can figure out x and y, yeah? So you pick the ones that are solved for what you need. If I give you equations, it's a little more, it's a little less straightforward. So the specific one you're asking me about, there's technically nothing wrong with just plugging what x is in here, but does anyone see a better thing to do first that leads directly to something?
You could add y squared.
Yeah. If I add y squared, that kicks a lot of ass. What is that?
R squared.
It's freaking r squared. And of course, it's that.
R cosine theta.
Now, if you circle that, I'm going to say something. I'm probably not going to take points off, but what should you do?
Divide by r.
Divide 1r away, yeah. Right? So then you get r equals 5 cosine theta. Do you guys know enough? Have we done a few? We've only done a few, but this is one of the more basic ones. What would that look like?
Circle. Or
Sitting on the which axis?
x.
X-axis, because it's cosine. Yeah, right? In fact, I mean, this, you would subtract the 5x, you complete the square, blah, blah, blah. It'd be shifted on the x-axis. Bam. You guys see that? If I brought this over, complete the square, it's only shifted on the x. It's not shifted on the y. So it's going to be sitting on the x-axis. Neato. Okay. Yes?
Is this like the final answer for
Yes.
the polar formula?
So if I give you this and say, convert this to polar, done. Yep. Now, real quick, what if I would have just put in, so what is x? X is r cosine theta. So what if I did this? R squared cosine squared, is that cool? That's what x squared is. Equals r cosine theta, left out of 5, right? Minus r squared sine squared. Yeah? Looks much worse. But what's the immediate thing I can do? Do you see 2 trig functions who, if you put them together, they're gonna like become something much better?
You become 1 with cosine
They become 1. Oh my gosh. So if you add this over, just like we did with that, r squared cosine squared plus r squared sine squared, 5r cosine. So if you pull out an r squared, you get r squared times cosine squared plus sine squared, which is 1, and then you end up right there. Yes? So again, if you don't see that, it's not going to kill you. You just got a little more simplification to do, right? So what you do, if I give you one of these equations, again, if I'm you, I don't know, if you don't memory dump, I don't understand you, right? Does everybody know what that means? You get the test and immediately write somewhere in the test all the shit you're supposed to know, yes? So then future you can go, thank you, past me, now I can just look at it and I don't have to freak out, right? I've had teachers that did not allow memory dumps. They said, you're not allowed to do that. I'm like, whatever, okay. So we wrote it and erased it, and we're fine. Anyway, sorry. Is that cool? What were the other ones like? Was it okay? Whoever asked that question, were the other parts of that okay? What about number 4a, for example? So, let me ask you, why is this cool? If I, watch this. What if I said, convert this, let me see if you guys understand. Convert that into a rectangular. That kicks so much ass. Does anyone see why? What is r squared? X squared plus y squared. What is tangent theta? Y over x. All right, sweet. And then you can multiply the x, and there's not much you can do. That's basically it. Yes? Do you think that's a function? That's a whole other question, but it looks like it's probably not a function, but you'd have to kind of mess with it to see if it is. Okay. All right, so what if I have this? So I could think, let me multiply both sides by r, because at least then I have r squared. Do you understand that reasoning? That reasoning kind of sucks, because what's r times secant? It's r secant. I love it. Yeah, that's what it is. But what I always get is somebody realizes secant is 1 over cosine, but then they multiply both sides by r, and somehow the r goes down there. That's some magic shit. Yeah? So I think we looked at an example like this. I mean, you wish there was an r here, don't you? And what do you wish was next to the r? You wish there was like a cosine sitting there, right? Can't you do both of those things? What can you do to both sides? Multiply by cosine. So I don't have to introduce an r. There's an r right there, but just multiply them up. Hey! So I got r cosine theta, which is x equals 1. So secant is just a straight up and down 1, which is neato.
Is that the x squared plus y squared on the tangent? Is that the final answer?
All you could really do is you could multiply by x, but it really doesn't do anything to it. Yeah. Okay. So that's one, if there's no immediate things that cancel or can get put together, you can stop. Okay. Yeah. Okay. All right, just to show you something that you don't, I'm not going to do this all the way. But let me write this like this. Let me subtract the y over, and let me put the x cubed there. All right, you ready for your worst nightmare? That is quadratic in y. Yes? Isn't that quadratic in y? What's the coefficient of the y squared? That's a. What's b? Negative 1. What's c?
Oh,
X cubed. If I'm talking about y as what is quadratic in, everything else is considered a constant. I could use the quadratic formula to figure out what y equals, right? We're not going to. Don't freak out. You guys don't get to see that very often. So again, this more than likely, this almost definitely, this is just not something you can make into a function, because you would have to make it plus or minus, right? If you try to solve for y. And something even worse happens if you try to solve for x. So if you graph it, it's going to be something. In fact, It's this, which is definitely gonna be some twisty turvy, curvy thing, okay. Okay, enough, sorry, okay. Anything else from that little section, or you wanna go somewhere else? You know I'm gonna give you, alright, just to let you guys know, this was the test I actually gave my class for the last few years. I just made it into a practice test. So this is what could have been given to you, right? But I decided I'm just gonna make it into a practice test, and I'm gonna make like a whole new test for it. Yay! Sounds exciting, Jeff. You know I'm gonna give you number one, and you know I'm gonna give you more to do with it. Right? You know I might give you like a second problem where I say eliminate the parameter. Yes? Okay. All right. So now you've seen several examples of how to eliminate the parameter. Some of them are not straightforward. You could try to solve for t and plug it in O, and sometimes that's the worst way in the hell to do it. Especially if you have some trig that you can kind of use an identity to put together, right? Maybe. Okay. Yeah, well, let's see. What if I had, for example, this? I want to use that for the test, but no, I'll give it to you guys. X equals tangent beta, y equals secant beta. And actually, yeah. So theta and t are very often used for parameters. If I have trig, we often use theta, but the book I noticed uses t exclusively. But let's just make this t just to make it more like the book. Parametric does not require t. It's sort of like the letter x. It's just a letter that's most commonly used. It makes sense that if we're dealing with trig, we actually choose the letter theta instead. Okay. Anybody have any idea how to eliminate the parameter here? Say again? You could, but it's not going to be good enough. What are your identities that you know? What's sine squared plus cosine squared? 1. Give me another one. Divide by cosine squared, you get tangent squared plus 1 equals. Okay. So immediately I can write what? X squared plus 1 equals y squared. Does everybody see that? Parameter eliminated. Right? In a more sophisticated way. Instead of just solving for t and just throwing in the other dude. Now watch. What happens if you do solve for t? What do you get? Pick one of them to solve for t. What do you get? Pick one solver for t. What do you get?
Arctangent of x.
All right. I get t is equal to the arctangent of x. So then what do I get for y?
Arcsecant of y.
No. I'm sorry. Solve this for t. Throw it in. So y equals secant of t, but t is this, yes? All right. This should immediately spur you to realize what you have to do there. Anybody? Think back to chapter 7, everybody's favorite. Use trig sub. Can you draw a triangle based on this? Isn't this x over 1? All right, so what triangle am I talking about then? Tangent, x over 1, so what side's x?
XY.
Yeah, the y side is x, I love it. And the x side is 1, yes?
Yeah.
And so this would be square root of x squared plus 1. So therefore y equals, what's the secant of this angle? And if I square both sides, I get this. which is the same thing, yes?
Yeah.
So that works, it's just, you know, but you can still brute force it, but sometimes you really can't. Okay. So what you're thinking about when you're trying to eliminate the parameter is, if you can solve for t and something kind of easily happens, do it that way. If it doesn't, there must be something else. And if you see trig functions, think trig identities, which is a really good review for the final, because you know me. You know in the final it's going to be some freaking trig identities. Yes? So you've been sort of like, I can just swim around those. No. Right. I'm going to populate that water of the final with a ton of freaking mines. So you can't swim around those. So you got to know your trig shit. Okay. Oh, number 3 on the practice test. Anybody try that? So it gives you y cubed minus 3y equals x.
Square. That's y squared.
Y squared? Thank you. So, I asked for 2, right? Because 1, you could always do something really straightforward. You can always just make the variable that's got more shit going on, make it t. So what would x be? T, Jeff, I don't know why I want that to be cubed. Right? That is your trivial solution for making, as for parametricizing something. Okay. Now it's up to you. I mean, I sort of made this a little bit nice because it's already solved for x. So what do you do then? You pick a function for, pick a function of t for what? Which variable, x or y? Isn't x already a function of y? So if I let y equal something, don't I automatically know what x is? So tell me, give me any function, go. Any function of t.
Cosine.
Cosine t. So then what's x?
Cosine squared t.
Cosine squared t
Minus 3 cosine t.
minus 3 cosine t. Now, real quick, do you guys understand? It could be any freaking thing, anything. Yeah? Any damn thing. Every choice you make might come with certain restrictions. So, for example, in this case, what's the biggest x could be? Is there any biggest x could be? No, I can let t be 18 billion and x is 18 billion squared minus, that's pretty freaking big, yes? What's the biggest, well, x is not the greatest one to start with, but yeah, sure. What's the biggest x could be here? You can do it, I know you can do it. No? What's the biggest x could be? What's the biggest cosine squared t could be? 1. Right? Or, and because it's 1, even when it's -1, it's squared, right? And then what do you want? You want to subtract at least. So what if when cosine is -1, this would be 4. You guys see that? So the biggest x could be is 4, and you can figure out the smallest x could be. Y's got its own trouble, yes? So, for example, if this, now of course this is perfect. This, what kind of a shape is this? What shape is this? If I were to graph it. Parabola, facing which way? It's not y equals x squared, it's x.
Yeah.
So yeah, this way, right? And the vertex will be, it'll be shifted that way a little bit. So it's going to be basically, actually I think it's going to be that way. Okay, so I mean something like that. So if I do this choice, I'm only going to be able to go to the y's that are 1 and -1, right? And I'm only going to be able to get the x, so I'm only going to get a piece of that. It's going to forever go back and forth. In your homework, there should be a problem where you get, the whole thing becomes this line segment, and you're basically going back and forth, back and forth, back and forth. Because again, when you use trig functions to define your parametric stuff, they come with limitations. So you can't ever get the entire picture if it requires outputs bigger than they can give you. You with me? What if I do this? That's still valid, correct? But what have I done now?
You extend it and
I'm going to get the exact amount that I would before. What's going to change though? How fast it goes on that trajectory, yes? And that's why some of the homework talks about how much time is it going to take. So, do you understand what I'm trying to say here? Parametric, you have almost an infinite number of choices you can make to parametricize something. But you got to realize, what kind of outputs do you want for X and Y? If you choose the wrong thing, it's not going to go far enough. How quickly do you want this thing to move? If you're making an aircraft, do you want it to go around that bend and kill everybody inside of it? Or do you want to maybe slow that sucker down, right? Maybe? Maybe? Okay. And again, I know you guys are always kind of worried about what the hell does this mean for me immediately. Please, dear God, Jeff. I'm not going to give you a problem where I make you overanalyze something and really understand all the ramifications of the choice you make. But I could ask you a question. If I chose this versus this, what would be different? Right? You don't need to get that deep. You don't need to do any of that. You should be able to tell me what would be different. Okay. Is that cool? Is that all right? I'm not going to give you something and say, tell me everything about it. How long would it take? Blah, blah, blah. No. The thing with, I'm going to give you a problem. So real quick, 6B is going to be the extra credit problem, right? And I might have another extra credit problem related to the finding a tangent line for polar. We'll see. So maybe I'll have like 4 bonus problems. 2 of them would be from section 10.4. So 6B is a problem that would only be in the bonus if it's on the test. I'm going to give you at least one problem like 6A. Did everybody try to do 6A yet? Does everybody understand how to even do it? If you're going to do 6A, what's wrong with doing this? And then plugging them in, getting the R values, right? Seems good. I'm making points, right? What's kind of wrong with that?
It's always going to be 0. Is it always
All right. One thing is, let me see. What did I say? Did I give us? Oh yeah. For far sine 2 theta, yeah. It's 4 sine 2 theta. That is always going to give me 0, right? But even if it doesn't always give me 0, what else is wrong with this?
You might not have enough theta values to figure out the direction it is.
Okay, good. Even more importantly, so yeah, you probably can't really see the direction necessarily, but because you'll be jumping so much, you'll be missing so much of the shape, right? So it's sort of like, I don't know if you ever played around with your resolution or your graphing calculator. In fact, I might try to do it here in a minute, just to show you guys. Actually, let me do that right now. I want to show this to you. Bump, bump. Here it is. Zoning, where are you? So in your calculator, if you put in there, here, let's go into polar. Let's do this 4 sine 2 theta, right? So if I just graph it as it is, we get that. Yay. Now watch this. If I change the window, look, see the theta step? Make the theta step equal to pi. that's too big. Let's make it to, all right, let's just make it to pi divided by 3 roughly, so it's 1. You with me? Okay, do you guys see that? Do you guys understand why it looks that way?
Yeah.
Because the calculator is just plotting only those things and then connecting them, right? So that's when you would get something like that. So if I improve theta step, in fact, let's make it better than it was, 0.01, considering I slow it down. There we go. Now it's really nice. If I make it something like 0.5, let's see what it does. It's still, so 0.5 is half of 1. It should still be sort of lightning-y. Should look a little Harry Potterish. There we go. Actually, less Harry Potterish and more Windows, like janky Windows. Looks like the Windows logo. There. Really cheap PC you bought, right? You guys understand that? So when you're doing this by hand, that's why I said the very first problem we did, I said leave some room between what you do pick. So then when you graph, you're like, oh shit, I need more. You can pick the things between what you did. Because what really gets hard is to have some stuff here and then have other points in between those points over there. And I think at one point I was doing that. You can tell how weird it was to try to remember which point goes to what next point. Does that make sense? So leave a little room in your table, and just in case you need more resolution. You're going to have your calculators too. I'm not going to stop you from plotting the damn thing first. Kind of informing yourself what the hell it's supposed to look like, but your work better show up in your graph. It better not be not enough work and then a perfect graph. That's not good. Okay. So I think there's something else I want to show you, but I forgot. Let's do that. Anything else on here? Like number 7, I'm still going to give you a problem like number 7. Because to be honest, that's a pre-calc question, right? And you're all like, I already did my time in pre-calc, Jeff. I'm like, okay, let's find out. Do you guys know how to solve number 7?
Do we set it equal to each other?
Set them equal to each other. And then what the hell would you do from there? Here, let me do this. So one thing I try to get students to understand when you're trying to solve trig equations, all the angles have to match. Otherwise, there's no way they can interact in a way that you can actually solve. So I have, if I set them equal to each other, I get sine 2 theta equals cosine theta. So then what do I need to do? Obviously, the angles don't agree, correct? What's one angle?
2 theta.
2 theta, and the other angle's theta.
Theta.
I love it. So what's the immediate thing you could do to remedy that? So that everything is talking about the same angle. Yeah, the double angle. So what's sine 2 theta equal to? 2 sine cosine, 11. Big mistake people make is they divide by cosine, which loses answers. You never divide by something that could be 0. Because then you lose answers, right? So what do I do instead?
Divide the cosine. Or
How would you solve this equation? X squared equals 9x. Subtract and then factor. Okay, what are you doing? Subtract. Cosine, yes. So 2 sine theta, cosine theta, minus cosine theta equals 0, and then you just
bring out the cosine.
bring out a cosine. I love it. Here, you guys finish that out real quick. Yikes. By the way, does this problem give you an interval within which I want the answers? How many answers are there to that? All right, we'll find out. The simple trig equation, something that has only thetas in it, if it has one answer, it has an infinite number of answers automatically. For example, if one answer was pi over 6, pi over 6 plus 2 pi is automatically another answer, yes? And I could do that forever, and I could go backwards, I can go backwards and forwards, yeah, right? So cosine theta equals 0, I call it, when I taught this to my pre-calc, I had a base answer, and then I had the rotations, right? So what's the most basic answer to cosine theta equals 0?
0. Oh, wait.
Oh, yeah, pi over
pi
2.
over 2, yeah. And 3 pi over 2.
Now how do you capture all of them then? Because pi over 2, 3 pi over 2,
Plus pi over 2.
negative pi over 2, right? How are you going to capture all the answers? Now, something you did back in pre-calc, but it actually relates to our series stuff, finding patterns, right? What is true about the top of that? The top is always going to be what kind of a number? The constant. It's always going to be what kind of a number? Odd. Right? So if you do k pi over 2, that's no good, because then that's 1, 2, 3, no. You need odd, right? So we should do, how do I represent an odd number? 2k is even.
Minus 1.
Minus or plus 1. I think I put plus in this, that doesn't matter. That's odd, right? So if k is 0, you get negative pi over 2. K is 1, you get pi over 2. K is 2, you get 3 pi over 2. You guys see that? You remember this from pre-calculus. You actually had to write the general formula, right? Okay, what about this guy? Sine theta equals 1/2.
Over 6.
Yeah, you should get 2 base answers. 5 over 6. 5 pi over 6, of course. It's got to be where sine is positive, so it's got to be the upper half. It's got to be the first and second quadrant. It's pi over 6 reference angles, both sides. One is pi over 6. That one's pi over 6. I love it. By the way, real quick, here's pi over 6. Here's 5 pi over 6. Can I go from pi over 6 to 5 pi over 6? Go from here to here and then back. Are they equidistant? So that's why I have to have 2 statements. I don't know if that came up in your pre-calc class, because sometimes you can write 1 statement to capture 4 things if they were all equidistant, because I'm just going to always be adding the same thing. But here I'd add 4 pi over 6, and then here I'd add freaking, what is it, Jeff? 4 pi over 3? I don't know what the hell it is. A lot. So this is where I could just do plus or minus what? So now I want to go from pi over 6. If I go all the way around again, I get another answer, don't I? So how do I represent that? What's a full rotation?
2 pi.
2 pi. So I'll just say 2k pi. Okay, maybe. So of course, if you actually had a problem, you would only need to have the primary intersection points. You wouldn't do all the infinite ones. Yes? But, still, I want you to remember how to do this. Okay. I might give you a problem like this, and I might be nice and just say, find all the answers inside of 0 to 2 pi. We'll see how I'm feeling when I make the test. So is there anything else from like the practice test or from the homework that still doesn't make sense? If I'm not getting a lot of questions, I could open up section 10.4 if you have a question about that.
you do, 1B?
1B?
Yeah.
Oh, okay. So if I want to get, let me show you a slightly different way. So how do I get dy dx for parametric? What do I do?
dy over dt?
Yeah, it'd be dy over dt, dx over dt. Let me show you one little thing. Let me show you a different way to look at it real quick. So that's pretty straightforward, yes? You got your y as a function of t, you take its derivative, blah, 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 yeah? So what's y in this case? I forgot. 1/2 t squared
Oh,
minus 5, right? Let me see if you guys, I like this way better, but I just showed you that way because that's what the book has. But what is dy? T dt, yes? Right? And then x is something, -3 cosine t. So what's dx?
3 sine t.
So then if I just do dy over dx, it'll be t dt over 3, dt. 3 sine t dt, the dt's cancel. So that's dy over dx. I like that way better, it's just cleaner. But I mean, it's the same damn thing up here. It's just here I divided the dt's explicitly, here I'm implicitly dividing the dt's. Do you see the difference? It's the same math. Math doesn't give a shit which one we do first or last. Now, here's the real trick. Is everybody cool with that? That's should be pretty straightforward. How do I get the slope that I need from this?
again,
Yeah, what t value am I curious about?
pi over 4.
Pi over 4. So now you just plug in a pi over 4 for t. You get your m. Right?
Listen, so the idea of the arc length is the same as.
Oh, wait. I'm talking about b, right?
Yeah, so it's not the arc.
Oh. No, it's not the arc length. No. I'm not asking for arc length. I'm just asking, I think part C is where I want the equation of the tangent line, right? Part B is just the slope. Like 1b, yes?
Yeah.
Okay. So I didn't ask for the arc length. Yeah. So once you plug your pi over 4 in, you get your slope. Now, real quick, how do I finish out what I need for the tangent line? How do we get these?
You plug t into x and y.
Say again?
You plug t into x.
Yeah, I know t is pi over 4. I know what x and y are in terms of t. I just plug that in. And I get what those are. I like it.
Would you prefer for us to bring the y1 part over and simplify?
How do you mean? Just add it over?
Yeah, for example, when I finished it, I got like y minus pi squared over 32 plus 5 equal to the other side factored out.
Oh, I see. And then you solve for y, yeah.
Yeah.
Yeah, it's generally, we generally solve, put it in a slope intercept form. Yeah. Cool. Yeah, okay. Not sure where you got a 5, but we'll see. This test, especially since we're not going to have 10-4 on there, normally the part of this test that would be the most difficult is me giving you a couple of like r equals this, r equals that, find the area that's inside this one, that's outside that one, so you have to find where they intersect and blah, 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 right? So this is going to be a little more nuts and bolts-ish. I mean, 2 of the 3 sections I'm testing you on are the basics, like the basics of parametric, the basics of polar. We got 1 calculus section that I'm really testing you on, and even that one is not that big of a deal, right? We do have the integral stuff. I don't think did I put an integral parametric on here? No, but do you guys remember how to do an integral parametric style? So if you have y is a function of t and x is a function of t, this would be the integral alpha to beta of the function of t here times, so dx would be g prime of t dt. So this would be f of t, g prime of t dt. Right? So you start with calc 1 and you just replace stuff. Yeah. Okay. So that is something I could throw on there if I wanted to. That's in the homework. I think that's the only kind of problem that's not on the practice test I might put on there. Yeah, okay. So this one should be a little more nuts and bolts-ish than your standard Calc 2 test. One section less than normal. The homework went okay, you guys? I got 2 pieces of homework from chapter 10 so far. It's not due yet, so, but still. Is it going okay? It's doing all right. Yes?
Did you try out 4B?
So when I see these kind of problems that convert from one to another, very often I'll say to myself, or actually all of math, I'll say, what do I wish was true here? So when I solve equations, I'm like, I wish that 5 wasn't there. Well, okay, how do I kill it? Yeah, I multiply by it if it's on the bottom, all kind of crap, right? So if I'm given this, I'm like, what do I wish was here that isn't here? Okay. Do you all agree? R by itself sucks. Because what's r squared? X squared plus y squared. R by itself would be the square root of x squared. That kind of sucks. So do you want to square both sides, though? Do you want to FOIL this out? No. What do I wish was in front of the sine?
R.
What do I wish was in front of the cosine?
R.
Okay. So I wish this was r squared, and I wish there was another r on that side, so multiply both sides by r. Yeah. So it doesn't always happen, but when you're doing something with equations, since you're allowed to do shit to both sides, you can kind of say, oh man, I wish this was going on. Okay, make it go on. Make it that way, right? Of course you can't do it. I wish this didn't exist. Erase. No, it doesn't work. So then r squared equals 2r sine minus 5r cosine. So that's beautiful, right? What's r sine?
Y.
Aquarius. What's r cosine?
X.
And of course, what's r squared?
X squared plus y squared.
Now, just to prep you, I decided right now to be a little nice. I might feel like I want to say find the center of this. In fact, what is this?
Circle.
Circle. Do you know how to find the center of it? How many licks does it take to get to the center of this stress?
Wouldn't you get
Don't lick it, by the way. It's not good. This is not good for you. Huh?
Radius. Is it the radius? Or the radius?
Do you guys remember? Anybody remember?
I can't remember what it's called. But I know they bring the X over.
Yeah.
You,
Bring that over, leave some room. Bring that over, leave some room.
complete the square.
Complete the square. Cool. Yeah. Because you want it to be x minus something squared plus y minus something squared, and then you know what the center is, right? Okay.
Oh, wait. Why does that give you the center?
Because we know, in fact, real quick, this is kind of cool. What is the definition of a circle? I don't know. See the picture. I don't know, Jeff. Anybody know what the definition of circle is? In fact, what is it about that that's a circle? Okay, that's a weird question. Isn't it?
Isn't just everything's the same radius from center?
Same distance. I love it. So it's a circle is the collection of all points that are the same distance from the center. Right? So let's pick an arbitrary point on the circle, and I want it to be some given distance, I don't know, let's call it r. And I want that to be true all the way around. So what's got to be true about every point on that circle? What must be true?
It's R away.
Right? What's got to be true? X squared plus y squared equals r squared. That's where the equation of a circle comes from. It comes from the way that we define it. So many, in fact, the ellipse, I don't know if you when you took pre-calc, did your teacher show you about the two foci, and if you do a string and you tie it to both, and you have a pencil go around, and then you can connect that to the actual algebra you do to create the equation of an ellipse. I have no idea what you guys got to see when you took pre-calculus. So a graph is a collection of points that have some relationship. That's all a graph is. So what's the relationship of all the points that are in a circle? They have to be the same distance away from the middle. So of course it's built on Pythagorean theorem, because the distance formula is built on Pythagorean theorem, blah, blah, blah. Okay. Given any relationship, how do I move it? In fact, where's the center at the moment? 0, 0, right? I mean, I'm making a... So how would I move that to the right 3? What would happen to the equation if I want to move that to the right 3?
X plus 3 squared.
Good try. Not quite. I'll move it to the right 3.
Minus.
Oh, minus.
X minus 3. Real quick, anybody still not like that fact? It's okay, let it out. It's minus 3 with the shit math. No? Nobody feels that way? Do you guys understand? Remember this transformations? It was always the opposite if it was inside with the letter. Why the shit does it do that? Because all of my inputs was the very first thing I do to any input. Any number I put in there was the very first thing I do to it. I take 3 away, yes? So what's got to be true about every input? It has to be 3 bigger to have the same output as before. That's why the whole thing moves to the right. They all have to get 3 bigger to overcome the 3 I'm taking away from it the minute it's in there, yes? Okay, that's why it does the opposite of what's in there. It's trying to overcome that loss. Yes? Okay, maybe. Okay. Is that better? Is that okay? And then I can do a similar thing with the y. I can shift it around, and of course that's why whatever's here and here tells me the center, because it's the transformation. It's how it's been translated. Is that cool? That's a beautiful question, though. I mean, that's the kind of thing that can kind of fall through the cracks. Okay. Anything else? For homework or the practice test or anything you're worried about? I will tell you this, I don't have this on the practice test, but considering I have to throw out section 10.4, I will more than likely have a little section where you have to plot various points on the polar coordinate system, and then the next problem will be use another graph now and plot r equals cosine 3 theta or something, right? And then the bonus will probably say go back to that picture and find the area of one leaf or something, yes? So that would be the bonus from section 10.4. Okay. I like it. In fact, I'm pretty much constructing the test in my head right now. I'll have a problem that everybody has to do that's got an r equals cosine 3 theta or something. Blah, 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 blah. One bonus will be find the area of one leaf, and another bonus will be find the equation of the tangent line at blah, blah, blah. Okay. So that's all from the 10.4, that's bonus. Okay, yes? Prove concavity.
Like, in the homework it was asking like, prove when is it concave up?
Oh!
And like things like that.
So that just pushed the idea of the derivative to figure out the second derivative, right? I don't know, maybe. I mean, I'll tell you this. You all saw, we went through it in class, how to do the second derivative of a set of parametric equations, right? I don't know if you guys remember it. There's some problems in the homework, you gotta do it. So all the same old stuff if you calculate the second derivative and you get some function of t, you can see when it's concave down, when it's concave up, just by analyzing when is this negative, when is this positive. None of the old calculus is different. It's just that we're being fed these equations in a different way, right? So you analyze it the same way as you did before. Yeah. Okay, maybe. So let me give you the answer key. You guys have a few minutes to look it over. We know if anything looks wrong. Okay, that shows it. Really hope my printer doesn't crap out on you guys. Number 6, I felt lazy. We had already done it in class, so I just scrapped what I needed for 6B. Again, 6B, if it shows up on the test, it'll be an extra credit. It is kind of nifty what you get for the area. So just to remind you guys, during the test, you can use your graphing calculator. You can, if I'm asking you to graph a set of parametric equations, you can graph that sucker, kind of see ahead of time what it's supposed to look like. Just use that information correctly. I always have somebody that just copies right out of the graphing calculator and their work doesn't match what it looks like, and it's like, come on. So use it to help you see where you might have made a mistake, you know, that kind of thing. So be careful about that. Same thing with polar. You can use it for polar. The one thing, look at 5C. Just to remind you guys, this is where you have to understand your inverse trig functions. All that work I did would have been exactly the same if the point would have been -3, 4. Do you guys agree? Right, so you see how the point was 3, -4, yes? If the point would have been -3, 4, all the work's the same, yes? I don't care which one's negative. When I square them, it comes out positive, so I still get R's 5. When I do the inverse tangent, it doesn't care which one's negative, just one of them is, so it comes negative. I would still get the -0.927, but what quadrant is -0.927 in? Real quick, what is this? If I go backwards, what angle is that?
-5/2.
-π/2. Does somebody know what pi divided by 2 is roughly? Everybody does.
1.6. Oh wait.
Yeah, 1.6, I like it. It's 1.57. So 1.5, 1.6, right? So that's -1.6. So where's 0.927?
In the middle. Oh, not in the middle.
Yeah, like a little, like basically in the middle. Just a little bit closer. Yeah. It's over there. So it's in the 4th quadrant. That's what's important. So the point I gave you, 3, -4, which quadrant is that in? That point, 3, -4, it's in 4th quadrant. So it matches. What if it would have been this? Is that the right angle? No.
No.
What quadrant is this in? Second. So there's 2 ways to do it. You either take pi minus the angle we got, 0.92, whatever it was, negative 0.9. Or you give this angle, but then you go negative r. Yes? You guys semi with me? So you got to make sure at the end, when you do the inverse tangent, why does it sometimes give you the wrong answer?
It's in the wrong quadrant, opposite.
Wrong quadrant, but why? Why does it just give me the right answer, damn it? Why? Because how did we make the trig functions even have inverses in the first place? Does the tangent function pass the horizontal line test? No, why not? Because it's not just this, it's that forever, right? Forever in both directions. So I had to cut it from negative pi over 2 to pi over 2. So the biggest output it can give me is pi over 2, and the smallest is negative pi over 2. So if I need to be in the second quadrant, it can't ever give me that. Poor little dude. We had to do that. It's the only way to make an inverse exist is to cut the domain. But the minute we did that, we're like, oh shit, we can sometimes get reference angles. Oh shit. So just make sure the point I give you and the answer you get are both in the same quadrant. Hint, hint. Okay.
So if it was flipped, then if it was flipped, we would just need to.
Yeah,
factor it
either you'd have to take this and make it the reference, you'd have to go pi minus 0.9, blah, blah, blah.
Okay.
Right? Or you could just say negative 0.99, blah, 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 that's theta, and r, you would make it negative pi.
Okay.
I really want that to make sense. Because r can be negative, that just means face one direction and walk backwards, correct? If I'm facing the fourth direction and walk backwards, I am in the second quadrant. I think I said fourth direction, fourth quadrant. If I can walk backwards, I'm in the second quadrant. Okay. Maybe. Yes?
So that means you could either keep theta as negative 0.927 and then make r go from 5 to negative 5,
Make r negative 5.
or negative 5.
Because that's the only way to get to that point.
Yeah.
So if I face this direction, but I walk backwards 5, I am at that point. If I said 5 or negative 5, I'm actually at two different points. I need to be that point, right? So the problem on the practice test has the negative there. We're fine because it actually ends up being the fourth quadrant, not a problem. If it would have been this, all the work stays the same. But I would have had to show up in the second quadrant. So you could say r theta 9 to whatever it was, I can't remember. Right? Pi minus, that would be in the second quadrant now, right? Okay. What was it? 927. Yay.
Question.
Yeah.
So what we would do if we get like a different quadrant in the answer? We have to like get a reference angle or something?
Yeah, the answer to an inverse trig function is at worst a reference angle. Because of the fact that we've restricted what it can tell us. It can't ever, so for inverse tangent, it can't ever give us a third or a second or third degree angle. It can't. Therefore, it will sometimes give us what is essentially a reference angle. Yeah. And it's because of the fact that multiple angles have the same tangent, right? So it's not a one-to-one function. That's why I had to truncate the domain to even make it invertible. Okay, you guys remember that? It's got to be one-to-one in order to be invertible. I love you guys. Some of you guys are looking at me like, this shit's wrong with you, man. All right. So it's got to... So if I told you the tangent of an angle is 1, can you tell me exactly what the angle is? Nope. Too bad.
45.
Huh?
Wait, what did you say? What was the question?
Tangent of an angle is 1. What's the angle?
Is it 45? Is it not 45?
Nope, that's not the angle I'm thinking of. All right, I was thinking of 5 pi over 4. Right? Are you with me? Okay. You guys understand? So one-to-one just means if I know the result, I know the input. If I know the input, I know the output. One-to-one. It only one thing goes to one thing goes to one thing. Right? Tangent, if I know the output, what could the input be? Well, technically it could be an infinite number of freaking things because I can add revolutions on, right? So it is completely not one-to-one. That's why I had to kill all the other clones, right? I had to stop my Phoenix initiative. I had to kill the other clones and only had the one in the middle. So that would make it one-to-one, but now it's one-to-one to a reference angle, maybe. Okay. Okay. How are they teaching pre-calc nowadays? I don't know. Okay. So I know in 180, sometimes you take a 180 with an instructor and they don't have a lot of trig in 180, and then you get to this class and immediately you need trig, right? So I wish everybody, you could teach calc and have so little trig in it, it's criminal, because Calc's 1 supposed to get you ready for Calc 2. Even if you're not going to take it, you're supposed to get ready for Calc 2. So anyway, so I apologize if, on behalf of my profession, if they didn't put a lot of trig in your 180. Because I'm sure you've seen, this class is a lot of trig. Yeah. Okay. Anything else, guys? From homework or from the practice test or just general? Okay. So we don't have to sit here staring at each other. If you're completely ready for the test, you could head out. That's fine. Right? I'm not even going to write your name down and do anything weird. If you have questions, please ask. Does everything look okay on my answer key? I'm averaging about a 97 on my answer keys. Yes?
For part 1C, I guess I just was confused where the point came from.
Oh, so from part B, I know that T is pi over 4.
Yeah.
So then you put pi over 4 into the definition of x and y. Right? Yeah. You double check me, I don't know. I might have plugged something in wrong, you never know. So if you put negative 3 times cosine of pi over 4, that'll be negative 3 rad 2 over 2. You can throw that in the calculator and see what that is. Yep. It should come out to be negative 2.1 roughly. Yeah.
Are you gonna specify, because I would typically ask for an exact answer, are you gonna specify the one decimal? like
Yeah,
you
in this
said?
problem, the exact answer would just be horrendous. So yeah, on the test I'll specify. And if I want an exact answer, I'll make it so that you can actually concisely give me an exact answer, yeah. So when I say exact answer, that means don't plug it in your calculator. Don't give me a decimal, because you would have to give me the infinite decimal place to be exact, right? Yeah.
Could you just quickly go over 6A?
Oh, okay. So those of you who weren't here last week, you might want to take a look at the video. Last Wednesday, specifically. But all you do is you make an R theta table, right? So we're doing R equals 4 sine 2 theta. So you want to have a high enough resolution. The nice thing is with most of these, once you're into the second quadrant, you should be able to kind of see where it's going, right? Once your inputs are in the second quadrant, you should maybe be able to see where it's going. So, for example, obviously I put 0 in there. I'm sorry, I put 0 in there. What do I get?
0.
0. Yeah. If I put, let's say, pi over 6 in there. And of course, here's where you can use your calculator. It's fine to give yourself some stuff, but it'll be 4 times sine of pi over 3, right? So it'll be 4 times rad 3 over 2, so it'll be 2 rad 3, which you can approximate in your calculator. Oh, just a second, dude. We're in the middle, right?
Yeah, like 3 point something, right?
Yeah, it'll be 3.5, 3.4 roughly. Okay. So now I've got these points to graph. So 0, 0. So I need my polar for sure, my polar graph paper. And here, guys, I did hand out some last time. I don't think I have, shoot, really? Is that all I have? Oh, well, I'll let you guys fight over this. So you need polar graph paper so you can do this correctly. So you would face pi over 6 and you would go out 3.5. So you face pi over 6 and you go out 1, 2, 3.5, right? You with me? So face pi over 6 and go out 3.5. And then what do I get if I put pi over 4 in? you get sine of pi over 2. Sine of pi over 2 is 1 times 4 is 4. So if I face 45 degrees, I go to 4. You see? Yeah, so I can see that it looks like it's going like this. Right? And then if I put pi over 3 in there, sine of 2 pi over 3 is rad 3 over 2 again, so I get 2 rad 3 again. I get 3.5 roughly. So another 3.5 there. If I look at 60 degrees, oh, this is terrible. Oh well. Now, if you go a little further, you'll see that it starts to recreate that same. It'll go to 3.5 again. It'll go 4 again. It'll go 3.5 again. It starts to recreate that same, and then it's going to go here and recreate this, and it's going to go here and recreate the same thing. So you don't have to make it a complete table. You can start to see where is it going, and then I can kind of fill in. Then I know it's going to be 3.5, 4, 3.5. So it should really go out to 4, but you get the idea, hopefully, right? 3.5, 3.5, 4, 3.5, 3.5, 4. Do you see what I'm saying? It's going to repeat that because that's what trig functions do. Okay. So this was a 2. We got 4 leaves. If it was a 3, I would get 3. Good. If it was a 4, I would get 8 leaves. Holy shit. So you know I'm not going to give you one that's 4. That would be insane. It would be a little bit tedious. Yes?
So if the graph has 4 leaves, do you want us to draw all 4 or just a single leaf? Like
Oh yeah, I stopped because we already did it in class. So, but on the test, you got to do the whole thing. Yeah. Yeah. It's funny when I went to do this, I'm like, holy crap, I'm pretty sure we did exactly that problem, right? Which I didn't mean to do, but apparently I only have so much creativity.
Just a last question. Is there like any rule of how much of a step we have to take or like take?
Say again, sorry? Oh, that's the thing. Notice how I'm taking small steps. In general, I like to do smaller steps unless I notice I can see what it's doing. So, especially because if I take small steps in the first quadrant's worth of inputs, I can then see kind of like, is it doing something the same thing over and over again, which I expect trig functions, especially sine and cosine, they're going to repeat very easily. Tangent and secant, those are going to have some undefined parts, yes? It's going to have some asymptotic, so that one I might have to be more careful about. But sine and cosine are nice. Once I see what it's doing, I can kind of like fill the rest of it in. So I tend to be more higher resolution with the simple sine and cosine because I'm not going to have to do much more past the first quadrant. I can kind of see where it's going, right? Plus, you guys are going to have your calculator, so you can kind of see what it's going to look like. I'd rather you don't, but hey, you got it. Why not take a look? Just show enough work to justify your beautiful picture, yes? Okay. All right, I like it. All right. How you guys feeling? I feel like you should get a shirt, survive calculus, and one thing I got was this shirt. Hopefully a passing grade, that'd be good. All right. If you're all tapped out, don't forget I'm in the Math Study Center. Got my office hours. My office hours changed a little bit, by the way. I don't know if you guys noticed. Mondays I'm coming in a little bit later because we tend to need more help in the tutoring center in the afternoon. So, yeah. Okay. Oh yeah, sorry, Melon. What's up? There's this. I don't know.
5, 11.
Huh?
11, 5.
What about 11.5?
You said I'm missing 11, 5. What I turned it in.
Oh. I'll still have to look for it. You gotta remind me. Maybe it's stuck. Yeah, it just means it's okay.